And we have not moved our Redis instance inside of Kubernetes because it is now a pet. So we have to maintain it very carefully. And we know this is also a fallacy in our infrastructure, but we do not want it to be monitored and managed by Kubernetes, because then it could move our Redis database at the scheduler's will, and then we have an outage. So that is the reason why it is still being using compute. We do use some Redis instances with our microservices bundled, for instance, just for caching or faster responses. But because this is the queue which like glues all instances together, it is still a Redis database. We have thought about using PubSub instead, but re-architecturing this part of the application for now didn't seem like a sane business proposition.
I have a question about hardware, about this controller that I have. So use case, for example, I do not have Wi-Fi. I have Wi-Fi, but I do not have internet connection.
Mm-hmm.
But app from my mobile still can control these bulbs. So I have a question: what inside this controller, and how do you sync it with cloud when internet connection back?
Yeah, so the Philips Hue light bulbs, they degrade pretty decently. So when you have internet connectivity, your for instance your mobile application will try to reach out via the internet to see if your local system is available, and if so, might use the internet connection. But even if you're at home, it will just start using the local connection. If you don't have Wi-Fi, if you don't have internet but still have Wi-Fi, then your mobile device is still able to reach your home system, so it will still use and interact with your system. And finally, if you don't have Wi-Fi, yeah, you can still use my competitor, the wall switch, to turn on your lights.
Question is, what the hardware and software in this home controller? Is there some, I don't know, Docker container that use same API that used, or what?
So the API which is being ran in your home is actually transparent to what we are hosting in the cloud. So that's also the reason why the app is able to connect with both, actually.
Are you using MQTT protocol?
No, we are not using MQTT, unfortunately. We are doing experiments with the new software to start using MQTT inside of the device.
So this control connected to the cloud using a WebSocket or just socket, and but you're not using MQTT, only just sockets.
Check. Did that answer your question?
Yeah, I'm thinking I have similar problem.
Otherwise, you can come to me afterwards and we can discuss it a bit more further.
Hello.
Hello.
I have less technical question. Is end-to-end testing on your side?
Once more.
Did you organize end-to-end testing if it's on your side?
So, if I understand your question, you want to know more about the testing of how we are doing the testing of this product, right?
Yeah, the whole end-to-end process.
Yeah, so we have multiple responsibilities. My company has an obligation towards Philips that this cloud infrastructure does what it needs to do, that it does what it needs to do. So we have extensive test suite that we, in isolation, can verify that the cloud infrastructure, given the correct input, generates the correct output. This is our obligation. Once we deliver our new firmware, our new software updates, we have a full integration suite with physical hardware at Philips, which does an end-to-end test to verify that the cloud connectivity still also works with hardware, because it is a combination between hardware and cloud. And then finally, we do a rollout to the beta users in production to observe if we have missed anything before we do a global rollout. Right. All right.
Anyone else? One more question.
So I heard you want to do multi-region. What's your biggest challenge to doing multi-region?
So our biggest challenge with multi-region is we we've been actually waiting for Kubernetes to mature with regards to multi-region support, and that's been progressing pretty steadily. The biggest challenge that we have with multi-region is we have these WebSocket connections to your home, but we don't have like a socket connection from the entry point to your home directly. So it might be that you are in a cluster in Europe, but your stable connection to our cloud is actually in US. And we need to solve that part of the equation, that we do cross-cluster connectivity so that we can link those two together. Right? Are there more questions?
Anyone else? We still have some time.
All right. Good. I would like to thank... Oh, there's one more.
My question is, why have you decided to work with Philips? As another company, the same.
So this is actually a very fun question. So in 2011, Philips was still one very, very big company. Philips Medical, Philips Lighting was the same company, and they were very enterprisey. So they had a lot of regulations and were very strict about procedures because they were also developing medical equipment. So they couldn't face any legal issues with regard to anything that they do. But this was really hampering their possibility to evolve and to make new products. So they had an inventor of this actual product, and the board of directors gave him like the undercover mission to find a partner to develop this outside of Philips, and he came to us.
Thank you. And am I right? If you want to work with another company, you can do it, or not?
Me?
Yeah.
Yeah. So I work at Q42. We are a project agency, and we work for Philips, but I'm not purely working for Philips.
Okay. Thank you.
All right.
I think that's it. Cool. Thank you, Mark, for great presentation.
Thank you all.
Welcome back. We hope you enjoyed that session. While we wait for folks from other tracks, let's take a question on security that we recently received. We're a small company that doesn't have the bandwidth to hire security experts. What do we need to do with Google Cloud to make sure that we're secure, compliant, and handling our user data the right way?
That is a great question. Security should really be on top of mind for anyone building a company or really any app or service today. These days, moving your data to a cloud provider like Google can be a big win in terms of improving your security model. Rather than having to develop and implement your own holistic security process, you can take advantage of everything Google has done to secure its own infrastructure.
Which is a great point. I mean, we've published numerous reports that talk about how often hack attempts happen to Google. It's something crazy like 300 times a day. The fact that we've had to harden our own offerings to keep our company secure means that we can also offer the same to you. You get the same protections that we build into Gmail, Drive, YouTube, and all of our services that are available to anyone who builds on Google Cloud. Steph, what does that actually look like for a developer?
Well, there's a lot we can talk about here, but I just want to cover a couple of top-level considerations. In terms of our software platforms, we have the basic philosophy: trust nothing and authenticate every time. That's really a philosophy of assuming someone is trying to get at data they shouldn't at all times and build a security model accordingly. And that goes beyond just software implementations. We look for opportunities to integrate hardware security mechanisms to make our security even more robust. To start, all your Google Cloud traffic travels on our private, secure, ultra-fast global backbone. We control this end-to-end, which gives us a lot of opportunity to ensure it's secure. And we transfer a lot of data on that backbone. Analysts estimate that by itself, it carries somewhere between 25 to 40% of all the world's internet traffic.
Which, I'm sure, is why we get so many reports of sharks chewing on our underwater cables.
All right, that's a separate story. But anyhow, that's on our network. But the thing that drives that is really the data centers, where each machine uses a custom Google design and produced Titan security chip. These chips are crucial to our network security since they define the machine's identity and drive all the encryption that follows. Now, I want to point out that this is all great. Google can keep your data secure once it's on our networks, but you, the developer, still have to worry about compromised access to the data. And what I'm saying is that you have to worry about phishing attacks. So on Google's side, we've tried to reduce the surface area for phishing by creating a consistent authentication experience for all our users, whether they're logging into Gmail or into an app that uses Google Cloud Platform APIs. By ensuring this consistency, we make it much harder for a bad actor to trick a user with a phishing scheme, because there aren't as many variables in a user's expectation. It also means that any two-factor authentication that users have set up will carry over seamlessly into the platform experience, with no extra steps for the user or extra work for the developer.
Right. The best protection against phishing is to remove the opportunities for deceit. And there might be some times when we miss something, but our teams are quick to shut down the security risk altogether until a fix can be released. We take user security seriously, just as much as we take data security seriously, which is also what developers generally care about. They want to make sure their data is secure and is safe as an entity of information. They want to make sure that data center fire isn't going to completely destroy their business.
Valid concern. I mean, this used to be a real threat, especially when it came to on-premise deployments, but Google Cloud was built as an extension of internal Google services that we use. And this means that you get a bunch of features for free simply by building with cloud. One of those is our data recovery assurance. First, all data at Google is backed up, and the backups are backed up, and those backups are backed up and logged, and we basically can't lose anything. So even if one data center goes down, we have duplicates of our duplicates. And the only change your company might notice would be a slight delay, and we're talking milliseconds here, or a short downtime if a new data center has to suddenly come online.
And that's what we really call redundancy. All right, let's head back to the sessions, and we'll see you again soon.
How many of us understand what scale is, basically? Right? Okay, so you build this application. When you build the application, initial version, prototype version, version 1, as we call it, has a few users, maybe your family, because they love you so much. And friends, of course, and then for some reason you hit something called the product market fit, right? Meaning people, users, actual users like your product, right? That's a good place to be. We agree, right? It's a very, very good place to be. Now, when you're at that place, your application starts to get traction. More people start using your application. More people start hitting your application. At that point in time, your application should be expected. There's a contract you're signing with the users of your application. You provide a specification of some sort, right? You provide some kind of documentation, right? And the contract you're signing with the people that are using your application, your consumers or your customers, is my application is going to adhere to this said contract, which is the specification, right? When more users begin to hit your system, maybe you are lucky and then you have thousands of, from hundreds of people, you have thousands and then tens of thousands and then hundreds of thousands. Now, when you're lucky enough to get there, it's expected that your application will still adhere to that same contract. Am I making sense? Even if it's small, right? When you get to that point, you are pretty much hitting scale, okay? We're going to do some tiny definitions. Scalability basically is a characteristic of a system system, model, or function that describes its capacity to cope and perform under an increased or expanding workload. All this English is pretty much what I just said. When your system has an increased workload, it's expected for your system to adhere or still meet that same contract that you signed when you were one user, when you were two users, when you were three users, when it was only your family that loves you, that was using your application. So basically that is scalability. Now, why should you care about scalability? Now, these are trivial things for profitability, basically. When your application grows, your application tends to become significantly more complicated. Begins to handle a lot more volume, of course, thank God, Abby. And users of your application will tend to experience blackouts. That's a normal situation. They will experience downtimes, they will experience challenges trying to access your application. Why? Because at the time when you're building the application, let me move ahead a little bit. At the time when you're building your application, you're one person. This was you hitting, typing, bashing code on your server, on your laptop, right? And testing your application. And it was working fine. It worked perfectly fine, in short. After some time, so trust me, the guys in Europe and they're your uncles. The people here, the people in Africa are your family. They're the ones using your application. So basically, people hit your application and then your application is still expected to perform, right? And under a reasonable amount of load, your application will still perform. Say 100, 200 users, it will perform because hardware is cheap. Abi? That's typical. Every single person here can sit down, write an application, and the application will perform well. If everybody here in DevFest, the 2,000 people in DevFest, decide to access that application, it will perform reasonably well without so much cost. This is where things become tricky. When your application really hits scale and you have people from all around the world accessing your application, we're talking formerly it was 1 request per second or 10 requests per minute, and all of a sudden you're doing 4,000, 5,000 requests per minute, right? Now that is a lot if you think about it. When you're doing 5,000 requests per minute, the most typical situation, now I don't have a checkbox there and I have that announcement. Why? Because startups, people that build these sort of applications that hit scale, that is the most common response. The response of saying, we are down currently for maintenance and we'll be back in a few minutes. That is the most common thing you see. All right, because a lot of people and a lot of us do not know how to handle scale. Our applications cannot handle scale. What I'll be sharing here today is just a little bit about how I have thought about scale, how myself and my colleagues, some of us have thought about scale, what we've learned trying to build a system that kind of scales to a certain extent, right? So to give you some information, so basically why I can stand here, I think, is because from a time when, the company I work for is Paystack, right? From a time when we're doing a few tens, a few hundreds of requests per minute, Paystack currently does 5,000 requests thereabout per minute. That is not counting a lot of other stuff, but trust me, it's a lot. And there are a bunch of things that the team has been able to do, a fantastic team has been able to do to make sure our application is still performant. Sometimes I go to the dashboard and I click the dashboard and I'm like, wow, this thing is just pretty fast, right? Normally one would expect that the application slows down at that point. What are the aims of thinking about scale or building for scale? Your application needs, as I've said, your application needs to reliably be able to handle intense load when workload increases exponentially. Now, on the one hand, you are praying and hoping that you scale, hockey stick, right? On the one hand, you're praying for a hockey stick growth. But on the other hand, you're very apprehensive that your system should be able to handle that. Because what happens overnight if from 100 users, you now start hitting 1 million users, you are going to be out of service. There's no two ways about it. You will be out of service for a brief period, all right? So your application needs to be able to handle that. Now, from a business sense, it's also very important for you because if you think about it, these users that are now hitting your system, they are hitting your system because they've seen value that you're providing. Now they're coming to you and expecting your system to perform in a certain way based on your specifications, based on the contract you have written and told them, guys, this is what my system can do. When you hit this endpoint, this is what happens, right? Now, based on that contract, they are coming to your system to perform those services or those functions. Now, when they come to your system and you are not or unable to scale properly and they hit slight shade, but a blue whale, or they see we are currently down due to maintenance. Technically, what you've done is you've, from a business sense, you've denied yourself of business, right? You've breached a certain contract that you had signed or that you had written down for yourself and your customer. So it's pretty important to think about our applications, especially now that we're building tons of applications. Now, Nigeria in the past 2-3 years, we've had, and we're still going to have more applications that are hitting scale. Applications that aren't just doing 1,000 users anymore. There are tons of applications, I'm sure everybody here can mention, that are hitting hundreds of thousands of requests a day, if not millions of requests a day. There are many applications that we have on our phones right now that I can bet you a lot of other users are using from everywhere in the country, right? I'm sure we can all think of those applications. So it's important for us to at least start thinking about this side of the technological part of your business. Yes, it's one thing to be able to bash out the code and write the code and application runs. It's one thing for you to not see a 404 when you clearly wrote the endpoint. That happens. It's one thing for you not to see a 503, right? It's another thing for you to be able to think about load and scaling of your entire infrastructure. Your entire infrastructure should be able to handle whatever load it is that is coming to your system. All right, so we're going to be talking about some of the things that you could do to help you in this regard. There are two main components of scalability as I see it. Availability is pretty important in itself. because availability is the property that your system has of being available when someone needs it. We have just talked about that, right? The second component is reliability, for which reliability is basically when your system, you write an endpoint to add 1 + 1, right? 1 + 1 we all know is 2. That means every single person that hits that endpoint must get 2 when he hits the endpoint, or an endpoint that does a simple addition. When you take one number and another number, and add those two numbers, you should get the sum, right? But a system that, if you add number A and number B, you expect it to give you the sum of A and B. It gives you a multiplication, or the what do you call it? It multiplies A and B and gives you a response. That system is not reliable because it's simply not reliable. It's not doing what it's meant to do, even though it is available. But we are going to talk a little bit deeper about availability, because at the end of the day, if your system is not even available, it cannot be reliable. True? Because there's nothing to even hit. There's no endpoint. There's no system to touch, right? So we're just going to be talking a little bit about availability. We'll drill down a bit about availability and see how we can go from there. I'm trying to rush on. I'll just rush a bit on slides so that we can move on quickly. So basically, there are a couple of things that cause your systems to be unavailable. As I've said, availability is the property that your system has for being there when someone needs it. When your clients or customers are trying to hit it, it should be there, right? Exhausted resources. How many of us have ever experienced this? Show of hands. As in, my hands, both hands are up. If I could sit down and save my legs. Like, your system, when your resources get exhausted, and the resources that could be exhausted, like, it varies from one part of your infrastructure to the other part of your infrastructure. It could be anything, right? I sometimes see infrastructure as Lagos traffic. Here's how I mean. Sometimes I sit down and I think about Lagos traffic and I think about my life. When there's a tiny accident, right, on almost any part of the express, what happens is that it affects you that you are in GRA Ikeja, for instance. You get something very, very simple. Now, most places in Lagos are kind of like that. When there's a tiny hitch or tiny blockade or something very, very small, it basically paralyzes the entire, yes, when it's raining, this one said there's nothing on the road. Like, it blocks everything. It stands still. That's how I see infrastructure. Here's what I mean. There are certain parts of your infrastructure, the smallest parts of your infrastructure, that if those things themselves are not well properly taken care of, it can bring your entire infrastructure down. Share a simple example with you. There was a time, oh yes, you had set up your fancy, servers. You had your servers running your fancy applications. They are all nice and tight. Your servers were doing 2% CPU utilization. Some people say that doesn't matter, but then again, it depends. Anyway, but then there was one particular box that you put at one corner at one time, and you thought that thing alone was doing authentication for something remote. How many of us have had to do something like that before? Nobody? Okay. Anyway, so you decide you have your nice infrastructure that works very well, but then there's this box that you were like, oh, okay, I don't need to devote a lot of resources to this guy because hardware can be expensive, right? So you put minimal resources on that box, and then you put up maybe let's say PHP on that box, or an Nginx server on the box, and basically it's meant to be serving requests. But you forget that there's this client that business might have gone to meet. Business might have spoken to this particular client, and let's see, maybe the client is trying to process jam results, for instance, and they are making multiple requests, and that server, that guy, that tiny server that you kept at one corner, for instance, is the one that is now hit. He's the one that is now going to bear the brunt of the request, because for some weird reason, our banks or any other service that requires a specific type of authentication, right? That authentication is what you put on that server to act as like a middleware between your infrastructure and the outbound dependency or company. Now that guy himself, you forget, because the servers are fine, and you forget that that guy is now choked. And what happens is he's choked, he's degraded, and probably for some weird reason, which we'll talk about, you don't have proper monitoring set up. Now the guy is degraded and he's there and he's suffering, he's crying for help, and nobody is there to answer, right? And after some time, requests pile up. Now you notice that other parts of your infrastructure are now beginning to slow down also. Now they slow down, they slow down, they slow down until it brings your entire thing down. One tiny box that you thought was insignificant. Please, doesn't that kind of sound like Lagos? Please, somebody. Like it's so much like Lagos. But anyway, we will overcome, Abi. So yeah, your systems can become exhausted. Another resource that can be exhausted pretty quickly is your database, your DBMS, whatever DBMS it is you are using. That can also, apart from the fact that your servers themselves, even the ones that you take care of, if you don't have some sort of rule that allows you to spin up servers quickly enough when you hit some kind of load, if you don't have that, your servers themselves can become exhausted resources. So you need to look not just at tiny fragments of your infrastructure, but every single thing, the whole 9 yards basically, is what you need to be looking at when you're trying to think about provisioning resources for your infrastructure. This is an interesting one. It's very simple. When your application grows, there's a need for the team to grow also. That is fact. So so that your application that you built alone in your room is going to grow out of your hands, definitely. You're going to have more people to manage the application, to manage different parts of the application. And if you're lucky enough, if you're lucky enough, you get very good engineers, but still the risks of many people working on your application bringing your system down is very, very real, and it's very, very apparent, because different people working on different parts of the application, they interact with the application in different ways, right? So there are some people, especially, so if you hear about people that have standards and all that stuff, right? We know about standards, coding standards, how you name variables, something as trivial as that. Different people interact with code and write code in different ways, right? So you have to do extra work to put those structures in place. Without those structures in place, right? The average person, the average way somebody interacts with, for instance, error handling, right? Might be different from the way somebody else interacts or does error handling. The way somebody might look at an outbound request, how you respond to, how you treat a response that comes from an outbound service is different from the way somebody else might treat it. Do you understand? So if you don't have those things in place to check how people are working, it could very well affect your availability. Now we're going to get to where you're talking about how to help your availability, blah, 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 where you put those structures, you put those standards, you put checks in place. You understand? Commit hooks and all those things. Those can help, those will help you. But like a child who is not trained, once you give him free rein, it's going to be messy at the end of the day. Oops. Outside dependencies, basically, the more your application also grows, the more you have to deal with clients, or sorry, not clients, but services outside. Now, those services outside can cause your application to actually even go down in itself if you don't handle it properly, right? Like I just mentioned. Coming from a point where, now some people assume, there's a lot of assumption made when interacting with, when building applications, when interacting with the internet, when interacting with third-party APIs, for instance. We assume sometimes that when you make a request, right, you will get a response. How many of us assume that? Sorry? Sorry? Everybody. But there are times when you really don't, you don't get a response for varying reasons, right? I don't know if some of us have heard of network partitions here. When network partitions can occur, the network basically, when the server is not available, pretty much, right? You will not, your system will time out, it could time out, or when you make a connection to the service itself, the third-party service, the service can actually terminate the connection based on the settings between yourself and the service, right? And there's something also called, there's latency that can affect your interaction with a third-party service. Now, what that means is the further your system is from whatever third-party service you're trying to interact with, right, the more the latency. And that's why some of us are provision servers. Some people that are provision servers here know that when you're provisioning a server, you should at least put it in Ireland or London, somewhere close, right, where you can easily hit, where latency is reduced. But you put your server in Singapore, and then there's a lot of latency. Now, that latency doesn't just affect, it doesn't just have to do with the time, right? Like the interaction between your server and that service it's not just time that is affecting it. It's not just the performance of your API. There's something called packets that would probably get dropped. Packets will always get dropped. Now, when packets are dropped, depending on the percentage of packets that are dropped, it could even terminate the connection entirely. Or, if you're lucky, TCP inherently has this thing called retransmission, so it can actually just retransmit the packets that were dropped. You understand? But that is extra latency because you have to do an extra round trip for all that stuff. So really, it can affect things like that. Tiny things that we might not even consider can affect us at the end of the day, right? So all these things, you should just know about them. Another tricky one is technical debt. We've heard of this one before now, right? Technical debt affecting your availability. How? Bug fixes, features that are not complete because you want to quickly push something, right? Features that are incomplete, bug fixes that are, you just keep pushing these things. The next time you might want to interact with the system, it might need to interact with part of the system that was incomplete. Now, the issue with that is it quickly becomes messy because your new feature that you have time to sit down and work on is interacting with the part of the system that you did not really think out properly, right? And what can tend to happen is bugs will occur at places where you didn't even expect. These are things that happen and shouldn't be taken lightly, all right? So technical debt is also something huge that can affect us at the end of the day. So we build applications well thought out. We should try as much as possible to build well thought out applications, try to fix bugs as quick as possible, minimize and keep trying to pay back whatever debt you have. Companies struggle with this topic everywhere, but there's a constant attempt and need to keep repaying the debt that has been incurred over time. Now, it's even worse when you've incurred certain amounts of debt and you are still incurring debt, which is a situation that a lot of people find themselves, right? So, but you see a lot of companies, a lot of startups have incurred debt. They're trying to pay back the debt, trying to build frameworks, structures, and systems in place to help them manage the debt, trying to build architectures that would help them minimize the ability or the ability to make that debt. Here's what I mean. If your architecture is good enough, your architecture is sound, there is a way architecture will prevent people from doing just anything. Do you agree with me? If you have structures and you have standards in place, if you have checks and balances in place, it will prevent your developers from just doing anything, thereby helping you, to increase the quality of your code base, not accrue technical debt, and hopefully you are repaying some of that debt with time. The sweet spot is not trying to pay back everything at once. Is going to be a lot of work because you have business to take care of. But the sweet spot is not accruing more debt. It is very, very important for you, like very, very important. So whatever you do, try as much as possible not to add to the load of nonsense that we have done, because we all build systems like that. They're like, oh, let me just push this thing. Especially for a startup, you're trying to hit the market as soon as possible. So you're trying to push out your application as soon as possible. You're not caring for the design of one thing or the other, right? You're just trying to push out. So it's important for us to also consider this as something that could hamper the way our system or the availability of our system in the long run. Like we've said, some of the ways you can actually start thinking about this thing is expect things to fail. Just expect that things can fail. Things can fail and things will fail. Your systems will fail. Your servers might crash, right? Your DB can be corrupted, because these things happen. Nobody is ever on a road to make sure his server crashes. Do you get that? Nobody attempts to make his server crash, but these things happen. But when they happen, how do you respond? How do you ensure that a server going down now will not affect your entire infrastructure? I know Netflix. It's difficult talking about this sort of things without talking about Netflix. But Netflix has this thing called Chaos Monkey. I don't know how many of us know it. Exactly. What Chaos Monkey does, we're writing applications, building infrastructure, we're testing, then we remove a variable or remove something and see how it works, then we fix it, then that kind of thing, right? That's what we're doing. Chaos Monkey basically does that in production. It doesn't just add a random variable or a random comma, it takes out a server, right? It takes out a server in production and they see how their system responds to that situation. You understand? Goals, Abi? As in, wow. So like things like that are very, 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 very impressive, and they are things that we can actually adopt, things that we can actually start working on. Other considerations when expecting failures, appropriate retry logic, for instance. If you're trying to hit an outbound service or you're trying to do a particular function or a particular task and it does not work, how are you retrying that particular thing? Right? How are you retrying? For instance, if you need to make a payment or your system has, how many of you have bought something from Amazon before? Good. You can buy on Amazon and your stuff will be shipped, for instance, but your charge or the payment might not happen immediately. In fact, it can even fail the first time, right? they've built their system in a way that they have certain amounts of retries, if we may put it that way. You understand? Now those retries basically are to handle cases when there are failures. Those retries are to handle cases when there are failures in the system, in the performance of your system, in the performance of a particular task. Are we out together? Bulkheads. Bulkheads are very interesting. How many of us have been on a ship? Yes, I know this is Lagos. Have you been on a ship? Okay, how many of us have seen a movie that there was a submarine that exactly, so those movies that there's a submarine that something happens, maybe someone shoots a torpedo and then it hits one part of the submarine and then everybody leaves that part of the submarine and goes to the next room and locks the door, right? Have you ever asked yourself, probably, why didn't that thing sink? Have you ever asked yourself, if there was a ship, for instance, that same thing happened to, they locked the door, they didn't patch the hole. Superman was not there. There was no Superman movie that he would come and patch, use his laser hand. He was not there to patch it all. But the ship didn't sink. What happened there was they contained that error, if I may put it that way. That thing that they did basically is a bulkhead. So bulkheads at certain parts of your application contain application errors from affecting other parts of your application. So there can be an error, and it can happen, but you've locked it somewhere, and it doesn't impact the rest of your system. Circuit breakers is a favorite to one of my colleagues. Basically, circuit breakers just let you know when your external services are down, right? So basically, the way your application works is, if your application is trying to probably have multiple services that you're trying to hit, multiple things that you're trying to make outbound requests to, any one of them can fail. We agree, right? Any one of them can be available for a variety of reasons. When one of them fails, your application, the circuit breaker pattern basically allows you to be able to automatically switch from that one to another one. There are people that have implemented this very, very well. There are patterns online that you can look at and implement. Bad customers, of course, how do you handle a situation where your customer system behaves poorly? Friendly in quotes, DDoSs can also impact you. For instance, they have a bug in their application that they're meant to hit you. They're meant to request from you maybe once every 2 minutes. They're requesting 300 times every 1 minute, for instance. How do you handle such cases? Those things should also be put in perspective when you're trying to make your system available. Mitigating risk. Sorry, I have to rush a little bit because I have time. I need to talk about databases. Mitigating risk, basically being able to keep your system available, involves a serious effort in mitigating risk. Now, how do you mitigate risk? And what are the risk factors that could happen, as we've talked? Server crashes. Your servers could crash. Your disk, your database could become corrupted. Your disk itself, your volume, your file system could become corrupted. Right? Your network calls could fail. Your package repositories could fail. Now, this is an interesting one. I remember not too long ago, there was a time when I heard that NPM was down. What happens when NPM goes down? You go down with it, Abby. That's what we're trying to prevent. You get? Or which other language? Ruby, the gem, Ruby gems, or whatever it is. Those repositories, they are systems that were built by people. You understand? And I think the error sometimes we make is that we depend wholly on those systems being available. But as every serious distributed engineer should understand or should begin to learn, anything that can fail on the network will fail on the network. While building an application, anything that can fail will fail at some point. The difference between you and the person that doesn't have a downtime is because you've not experienced it yet. Monitoring, very important. Very, very important part of keeping your systems online. You need to have efficient monitoring. You need to know the health of your servers and your application. You need to know how these things are doing. All right? I'm not going to say too much, but there are tons of monitoring tools that we're going to go and look up online. It's very interesting. I need to rush and get to this place. This is a favorite of mine, the data layer. The data layer is very important when building our applications. Now, depending on the data model or the type of data management system you employ, right? It is important for you as an engineer to know the limits of that system. Here's what I mean. I'll take a simple instance. Something as simple as designing your database properly. We're talking about scale, Abi. As a simple practical instance. The data type, character. We know car in a certain RDBMS. And we know varchar in a certain RDBMS. I need someone's name, short's name, Ade. If we store Ade in a field in our DB, right? Ade is 3 letters. Okay, let's say we're going to have a standard 3 letters for names. And Ade is stored in our DB. Ade is stored in a car field, car column, right? Meaning it's going to take, you say car 3, right? That means only 3 characters. Do you agree? And let us assume that one character is one byte, right? Cool. So if we decide to make the decision to store Ade in a car column, and we have 1 million names, right? How much data are we using to store those names, for instance? 1 million times 3. It's simple. It's 3 million bytes, right? But we decide to mistakenly use, yes, give me a second. We decide to mistakenly use varchar to store that same data. Now, the funny thing about varchar, which some of us might not have known, is that varchar uses an extra 2 bytes to store the length of the string. That means, by default, we're using 5 bytes for every single name, regardless of the fact that it is 3. Know your tools. Because the simple thing of knowledge there would have helped you save 2 million bytes. And we'll get to a point, since we're talking about scale, that's not the only thing you're storing on your column, you're storing many other fields. Now, some databases try as much as possible to load the entire table into memory. Right? Yes, they load the entire table in memory. Now, if they load the entire table in memory, it makes it easy for them to be able to do less I/O. So they don't go to the disk, because your data files are actually stored on your disk. So they don't do I/O, they just pick from memory, and then it's very fast. It works. But let us assume that because of mistakes like this, you consume more memory than you should on your table. And it's not enough to load your entire table into memory. What happens then? 2 things. Either you scale horizontally, spend money, or your queries become slow. Something very simple. We need to understand how our tools work. Something as simple as even lack of indexing. If we don't index well, for instance, an index is like a glossary, like table of contents for how your data appears. So let's say you do all these design things and you design it properly, you put the right data structures, you do everything, you store it in memory, and still you're having 70, 80, or 100 million records, and you're not indexed. You've not indexed your tables properly. What happens is that your application slows down. You are breaching that contract that we signed initially. Are we together? Right? So proper indexing could help you a lot in terms of being able to deliver the quality of service that your customers expect. And these are the things that you need to consider when you're trying to build for scale. It's another simple instance of using things like enumerators. There are different ways databases are implemented, enumerable values in the DB, in the DB itself. Now, some of us might decide to say, okay, we're using an enum here, and then we're going to join on a table that appears to be an enum. Right? So, for instance, you're using an enum for black, white, and green on this table. and then you're joining to another table that has black, white, and green as text. But you forget, or what you don't know, is that the enumerator values themselves are integers. Those values are integers. So you can go to your table, if you have any enumerated value, any enum value, just go there and then type a query and add +0 to it. You see the integer value would come out, not the string value. Do we understand? So things like that, considerations like that, considerations like that are things that we need to put in mind when we're trying to build for scale. They are tiny things, they are simple things, and we learned this thing in Database 101. Sorry, give me a second. We learned these things a long time ago, but there are things that are now coming back to bite us because we've hit scale. So there is no magic, technically there's no magic formula for you when you want to scale. Because it's the same principles. The same, you go back, when you want to scale, you go back to first principles and apply first principles to whatever it is you are building. Then your system is more capable of handling that load. It's pretty basic. Partition is also something that can be very, very, important. After you've done your indexing and you've done your design, you've designed properly, you can also partition. And that's when I was having a conversation with someone today, and that's when the choice of technology becomes very, very interesting, because you need to make certain types of trade-offs. So for some systems, the partitioning scheme is very, very interesting, very good. Some systems allow you to shard properly. Some systems, not so much. Some systems allow you to have clusters or clusters upon clusters. Some systems, not that much. Some systems allow you a concept of eventual consistency. Some not that much. Some are able to handle, in quotes, web scale. Some, not that much. So knowing whatever tool, whatever implementation, whatever thing you are using to work is very, very important. And it would help you at the path, or on this path of scaling. Now the path of scaling just requires you going back to the books and then actually reading and finding out things that you did not know when you initially built your application. At the end of the day, that's what it's all about. Are we together?
Today our topic will be about the building blocks. I will cover a bit at the beginning about TensorFlow, which is an open source library. Basically, it was built by Googlers, and they made it an open source. I will talk about how to use your own training data, so the data that you already have, and how to also benefit from the pre-trained models in Google. Machine learning means feeding this model with huge amounts of data, where this data has been already classified with cat or dog. And then the model all by itself will be able to detect whether this image is a cat or a dog. So as I said, this is an example. I want this session to be interactive. Come in, and if you have any question, do not hesitate to interrupt me at any point. We can go through your questions. So one example is that, for example, if I want to classify this image to be a cat or a dog, as I said, we can use machine learning, where we have to feed this model huge amounts of data with images of cats and images of dogs equally, so that this model can be able to predict through these different images whether it's a cat or a dog. Now, how does it go? We have a certain input layer. أنا ما راح أفوت into the details of behind the process of doing machine learning, but basically what happens is that you have these different input layers, these different models that are being classified, and then with activated neurons and mathematical analysis, we are able to predict whether it's a cat or a dog. So, for example, if this image is inputted into our model, it will be divided into different pixels, and in these pixels, we will be able to predict whether it's a cat or a dog. I will go back to the very basics of machine learning. It's a very simple example. I want to predict the house sale prices in a certain town. So let's say, for example, I have only this data, which is very simple, and it's not enough, abadan, to be able to predict and to create a machine learning model. I have, for example, for 1,000 square footage, the price is 100,000, and for 3,000, I have 300,000. طيب, if we want to predict how much would a 2,000 square foot house sell for, how much would it be? So this is very easy. This is how. بس أنت كيف وصلت لهذه النتيجة? You did a linear model. You created like an equation in order to predict what would be the new input and get the output. So this is basically a very simplified way of explaining what is machine learning. You have to look at the data at the beginning. You have to get this huge samples of data. Now, this is just a very simple example. Then you have to create this type of linear relationship or linear model. It depends as well on the case that you are trying to solve. So sometimes it would be good to solve a problem or a machine learning problem linearly. So we have inputs of numbers, and then we have to get the output. Other times you would need deep learning deep learning models. Now the deep learning models we can maybe go into another session, because it takes a lot of time to explain what is deep learning machine models. But basically, it means that you have different neurons, as I mentioned when I showed you the images. These different neurons, they will run over mathematical computations in order to predict whether, for example, this image is a cat or a dog. Hala, in this example, it's just numbers. We're just predicting what is the price of a house. This is where we predict. Hala, we have to revisit our data. This data is not enough. What would you say would be additional data that you need to have in order to predict the sale price? Location. Very good. Color. Okay. Quality of the house, مثلا. Year of building. صح. Okay, so you have very different inputs. You gave very good suggestions, but في كمان other suggestions. مثلا the crime rate. How much is the crime rate in this region? What is the school rating? Do we have schools nearby? Do we have hospitals nearby? Are we close to, for example, a highway, or are we very far into town? So you have different inputs that you have to also consider whenever you want to build your machine learning model. And this is where it takes a lot of effort and a lot of time for a data scientist to create the machine learning model. Now, this is where we will come into two ways to leverage what is machine learning. We can either train our own model, so we can get this data. مثلا, we are trying to create a model that is able to predict what are the prices of the houses. And in this case, we are training our own model. We are getting these different inputs of data, and we are classifying them. We are checking, for example, does crime rate make a difference or not? Does, for example, the type of the income in this region, does it affect or not? So on and so forth. So you have more control and more flexibility when you are training your own model, when you are getting this data and you are trying to build this model. However, the cons is that it's a very steep learning curve, and it requires trial and error to get it right. So you have a lot of work to do. You have to get this training data, you have to validate this data, and then keep on feeding your model and training it in order to get the computations and the predictions right. And then you have to test your data again with getting new inputs and new data so that you are sure that this model is robust enough. You have to also check if it's biased or not. So for example, let's say I fed my model that has to predict whether it's a cat or a dog. I fed this model with a huge number of pictures of cats and very low number of dogs. So definitely my model will be biased because it will predict more, there will be a higher probability to predict that it's a cat rather than it's a dog whenever I have to feed it a new input. Another way, instead of training your own model and going into the different steps, and we will talk a bit about TensorFlow when we want to talk about the training your own model, there's another way where you can also use our pre-trained models. So what Google offers, Google, by the way, supports both and helps you in both. It helps you in training your own model by offering you, for example, TensorFlow, which is an open source, and it has huge number of flexibilities of functionalities that you can do on TensorFlow. And then you can also host this TensorFlow training model on our ML engine, which is a managed service by Google that provides you with the computations, with the compute instances in order to train your model. And we also have our pre-trained models. So I'm sure you're very much familiar with, for example, translation. Who here has tried translation on Google? Okay. Who here uses photos and has facial detection and Beato? Yes. Okay. So all of these different machine learning APIs, they're all integrated inside of our products. And you can also use these pre-trained models whenever you want to create your own solutions. So let's say, for example, like the case where Omran has explained about dialogue flow and creating a chatbot. You can also create your own chatbot by using these ML APIs. So this is where it comes with the pros that you do not need any ML knowledge. You don't need to train your model from the beginning. You don't need to get this huge amount of data and then have to classify it and go through the training and the testing and the validation. You can integrate them into your apps with just a few lines of code. It's very simple, and I will show you in a demo. The cons, however, is that you have less control and flexibility. What do I mean by less control and flexibility? So, for example, I'll show you later. Let's say I'm using the Vision API, and I'll talk about the Vision API more in depth in the next few slides. So in the Vision API, if, for example, I'm a company that has chairs, that sells chairs, different types of chairs, the Vision API will not help me a lot, where, for example, if I feed it a chair, it will give me, okay, chair. Then I feed it another type of chair, it will also say chair. So this is where I do not have a lot of control and flexibility. However, Google has solved this problem by providing a new product as well, which is called AutoML. And I will talk about AutoML later as well. So AutoML will come in between. AutoML will help you benefit from our pre-trained models, but also allow you to get your data in order to predict even more specifically to what you need, in order to customize our pre-trained models. Is it clear so far? Yes. Okay. Anyone has a question? No. Okay. So as I said, we have two types of machine learning, how to solve our machine learning problem. We either use, you either use your own data to train the models, and this is where TensorFlow comes, or you, and then you will host this solution on a machine learning engine because it's a managed service, so you don't need to have this pain of for example, buying servers and then spinning them up and installing all of the software, and in case one of these servers is down, then you have to replace it with a new server. All of these different pains that you will have in order to host your TensorFlow machine learning model, you will not need them when you're in the cloud. I'm sure you're familiar with the benefits of the cloud, how flexible it is, how it provides you with an infrastructure as a service, platform as a service, and software as a service. So this is an infrastructure as a service. It provides you with a managed service of having to host the TensorFlow on instances, and Google will manage the rest. It will scale the instances as much as you feed it with data and with computations. I will talk as well about the hardware that is found in the Cloud ML engine, which will also speed up the training of your data. And on the other side, our pre-trained models, as I mentioned, we have the Cloud Vision API, the Cloud Speech API, natural language translation, Cloud Video Intelligence as well, and we have many others. So I didn't include all of the APIs. Yes? Yes, yes. So whole pre-trained models, they are APIs. So you will have to create HTTP requests to these APIs. Yes, you are right. So for example, let's say you have created an application where you want your users to store their photos on your application. You can use Cloud Vision API in order to benefit from this pre-trained model that we offer, that whenever a user gets to upload a photo, it will be able to classify it or to detect the faces, to detect any other information that you have. And we have a huge number of documentations on every single API that where you can benefit a lot from the functionalities. Yes. Are they free? No. You have a free tier. So for example, you have up to 1,000 requests per month, which are free. And then you will have to pay, yes. But you have عندك a certain limit where you can use it for free. In all of the products. Even for example, not only in these products in GCP, you also have in other several products where you have a certain limit where it's free and then you have to pay. I think someone in the audience talked to me before the session. They said that they're using TensorFlow for medical computations, or maybe she's not here anymore. Anyway. So TensorFlow is not only for machine learning, it's also for computations and creating algorithms and mathematical computations. So it's an extremely powerful open source library. You can also do different mathematical algorithms. It doesn't have to do with machine learning only, but the idea with TensorFlow is that you get to create a graph. It's called the flow graph. And this flow graph, it operates over tensors. So tensors are n-dimensional arrays. I will not go into the details of TensorFlow because it's very exhaustive. There's a lot of information that you have to get over TensorFlow, but this is just an overview of what you can do when you want to train your own model. You have a flow graph where the data will flow into the computational framework, and one of the benefits of TensorFlow is that you can build this model but not run it until you need to run it. So this is where you get to benefit, for example, from storing or from having to configure these different servers and hardwares that you need before having to run the machine learning model training. And what's mostly important is that you can train on CPUs, GPUs, and TPUs. So I will talk a bit about TPUs later, where TPUs is specifically found in GCP. They are CPUs specific for TensorFlow. So they're called TPUs, Tensor Processing Unit. And they are extremely powerful because if you also have experience with training your models, you will know that it takes an extremely amount of time. And you need to have the results as fast as possible so that you are able to change your model from the beginning in case it's not giving good results. So for example, one of the tests that we made at Google, we created a model, a machine learning model, where there was a game with different balls. I will not go into the details of the game. But we created this machine learning model, and we first tested it on CPUs. It took us about 8 hours, and then on GPUs, it took us about 5 hours, and then on TPUs, it took us 3 hours, and then when we increased the number of instances by using ML engine, where it scales, it took us 1.5 hours. So there's an extreme reduction whenever you change the hardware so that you're able to get the results faster. This is one example of what TensorFlow can do. As you can see, you have, for example, this image, which has a huge amount of pixels. And then we want to have a starry night type of figure of this image. Then you're able to create the image which is found at the far. This is a very interesting documentation, by the way. And I think, yes, it's on GitHub. It's also available. The thing is that for every single pixel, you will have to do mathematical computations on every single pixel, and which will take a lot of time and a lot of processing power. So this is why you need both TensorFlow, which will ease the computations, and then you have the TPUs, which will speed it up. Now coming to the machine learning APIs. Okay, so we had one type of problem where we had to train our own model. We have our own data. Now let's say, for example, I have this image classification problem. I want to classify the apples and the oranges. How can I create my model so that it can detect? Color, okay. Okay, well, branch, okay. طيب, if I fed it the what? Texture, okay. The branch, okay. طب إذا شلنا البرانش. Okay, it's really hard, ما هيك؟ form بس فيهم يكونوا بيشبهوا بعض كمان. يعني إذا قلبناها كمان للأورنج هيك، أو إذا جبنا غير نوع تفاحة كمان it will be even harder، صح؟ سوري؟ the specs هول النقط، أوكي. إيه بس هلا وقت صارت أسود وأبيض صاروا شوي، في هيديك صار عندها شوية specs كمان pores، لا؟ صح، visual كتير صعبة. So this is where sorry. إيه كمان إذا شلناها. Okay, so how will you be able to solve this problem is if it's really hard, and then you will have to get huge amounts of data, and then it might also not be able to predict this accurately. So this is where ML APIs come in place. This is where Google helps you to predict these two different types of fruits. So Google has huge amounts of information. What about a dog and a mop? هون هينة ما هيك؟ مين بيقول إنه هيدا كلب هونيك؟ لا، صح؟ طب إذا كان هيك؟ Okay. So machine learning is learning rules from data. You have to have huge amounts of data so that you're able to predict. So Google Cloud is trying as much as possible to integrate machine learning in all of its products. And we are constantly adding these different machine learning features into our products. So I already talked about Smart Reply. We have Photos, we have Translate, Cardboard, YouTube, Drive. For example, when you want to search in Drive, it's also very efficient, and it's based on machine learning. It will also predict, for example, what will you search for next? What's the most searched for document that you have in your Drive? So on and so forth. For example, in Play, it will also provide you with recommendations. So it will know, for example, your profile. What do you like most about? Yes?